So I'm Pat Schlatter, and I'm with Foba Laser Marking. I've been working with the Foba group since 2015. The thing that's changed probably the most in laser marking technology is both the interfacing and the equipment itself. It started out with, say, a teletype, paper tape interface. The power supply for a laser, to achieve a 50-watt laser, you needed about 3.5 kilowatt of power supply, and you need another 3.5 kilowatt chiller to cool it. And each of these required three-phase power. Fast forward to today, and now we can do this with 120 volt single-phase air-cooled device that is no bigger than the size of a PC. And you can use the latest, greatest Windows software with that machine, fully integrated from the graphics side, and it's really quite more user-friendly. The biggest challenge that companies run into is deciding which laser source will achieve the mark in the variety of materials that they want to laser mark. They're actually more specialized today than they were. You will find one laser, say a UV laser, really great for white plastics, whereas a universal IR laser would be good for a wide range of metals and a range of thermoplastics. But it is a combination of choosing the right laser source. And of course, there's so many companies to choose from that it really comes down to is doing a due diligence on these companies and their capabilities. With the Foba system, it's all about having a camera integrated with the marking unit. And the fact that the software is seamless with both, and the ability to do what's called intelligent mark positioning. So you can create an alignment model to align the mark to the part. And then you can do a pre-inspection, post-inspection. You can also do optical character verification, and you can do code validation. These are all features that are available. And then that can be tied in with customers' MRP system. So for a full, complete suite of tools for the end user. So a class 1 system is actually where 39 microwatts of radiation or less would be exposed to the user. You have special safety windows that handle that. You have guarding so that you cannot operate the laser whenever it's not in that condition. Whereas a class 4, it is significantly higher output, and you can cause both eye damage, and there's also the exposure to skin that potentially could happen with different wavelengths of laser and power levels. So the customer should always be looking at purchasing a class 1 system. Class 1 is eye safe. It is the least requirement onerous on the part of the user. They do not have to worry about the reporting on a yearly basis necessarily to CDRH. It is clearly the better way to go. A class 4 system would require that an integrator would need to build a class 1 system for them. So it's not ideal for the manufacturing environment. I see the laser marking technology moving towards true 3D marking, along with vision, integrated vision to go with the 3D, and the ability to do pre-post inspection, to do optical character verification, code verification, validation, and also having all of this tied in seamlessly to MRP system, and also to customers' maintenance software. Foba was, I think, the first company to, from the ground up, write a piece of software that has the vision system integrated fully with the marking software. And it's a very user-friendly interface, and it really does work. A lot of other companies had tried to come up with it, but it didn't quite fit the bill. But Foba now has over 20 years of vision system integrated with their laser marking code. First, I would identify the materials you want to laser mark. Secondly, I would then search out the laser companies that you feel have support, service support, and capabilities in your local area. And I would then go and have those samples produced so that you can see that it meets your objectives. But I do think that you want to look at a company that's been doing this for a number of years and that is willing to supply a turnkey solution.